Hello everyone, I hope you're all doing good and you all are very well. So, welcome back to my YouTube channel. It's Crack Neat. Pretty healthy you all should be because this is the time of coronavirus and we have to take so many precautions. Do wash your hands so many times a day. Use masks and use gloves as well. And also try to stay away from people if it's not too urgent. Some precautions you will have to take because health is also very important. Without health nothing is there. Okay, so start with the studies. Today we'll be doing with units and measurements part 2, in which we'll be covering dimensions and its applications. Already part 1 is uploaded, you can check it out in the video section, in which I have covered the basics of dimensions, rather basics of class 11, from where a child needs to start his preparation for NEET. So without wasting time, we'll start with the dimensions. Okay, so write down what is a dimension. First of all, we'll be seeing the definition of dimension. Write down, it is the power or quantity, or rather you can say exponent, the fundamental quantity must be raised to represent that quantity completely. This is the definition of the dimension. Basically dimension क्या होती है? ये होती है पावर या फिर एक्सपोनेंट, जिससे एक फिजिकल क्वांटिटी को रेस किया जाता है. मस्ट बी रेस्ड यानी कि फिजिकल क्वांटिटी की कुछ पावर जो रिप्रेजेंट करती है क्वांटिटी को कम्प्लीटली, उसको बोलते हैं डायमेंशन. सो व्हाट इज इट इज़ द पावर टू विच फिजिकल क्वांटिटी इज रेज, यानी कि कोई भी फंडामेंटल क्वांटिटी के ऊपर जब पावर दे देते हैं तो इट बिकम्स द डायमेंशन. ठीक है. ओके, सबसे पहले वी शुड ऑल नो दैट सी देर आर टू टाइप्स ऑफ क्वांटिटीज. Write down, there are two types of quantities: fundamental quantities and derived quantities. I have already discussed about these quantities. All right, so see, there are total 7 fundamental quantities which we should all know. Fundamental quantities are independent, they are not dependent on anything, whereas derived quantity, they will always depend on fundamental quantities. I'll give you the examples. First of all, let us see the 7 fundamental quantities. We should all know them. Also, how to write a dimensional quantity, we will always put that in a square bracket. Fundamental quantities, write down, first is length. So how will we represent length dimensionally? Write down in square bracket, and length is L. Then mass is M. Then time is T. Alright, then fourth quantity is current is A. Alright, then fifth is temperature is K. Then sixth is luminous intensity is CD. And last is amount of substance, as we read in chemistry. Amount of substance, that is represented by mole. These are what? These are I'm so sorry. These are 7 fundamental basic quantities which we have to remember. And also, whenever we write a dimensional quantity, we write it in this form: m to the power A, L to the power B, T to the power C. This is the standard way to write a dimensional quantity. I am starting with the very basics of class 11. so that nobody faces difficulty. Still you have any doubt, you can very well comment in the comment section. Alright, so this is the standard way to write a dimensional quantity. किसी भी डायमेंशनल क्वांटिटी को लिखने का स्टैंडर्ड तरीका m यानी कि मास to the power a, l that is length to the power b, t that is time to the power c. So let us see some examples. Per unit volume, we know what is mass, it is m. What is volume? Length into breadth into height. Ultimately they all are length, so m upon l into l into l. So we can write m upon l cube. I just told you what is the standard way. M to the power a, that is 1, l to the power b, that is 3, and t to the power c, since t it's not there, so we'll write 0. So this is the dimensional formula for density. M to the power 1, l to the power 3, t to the power 0, l to the power minus 3, sorry, it's in denominator, so it will become l to the power minus 3. Alright, okay. Then guys, very important thing, which book you have to follow for physics. I followed, guys, S.L. Arora, and believe me, it's a wonderful book. See, you can follow any book. H.C. Verma, it's for IIT level basically. S.L. Arora, D.C. Pandey, any book you can follow, but I followed this one and I was able to crack NEET easily. So you can use this book. Also, whichever book you use, stick to one book. Don't go here and there. Stick to one book. Practice it as many times as you can. Since I follow S.L. Arora, so I'll be teaching upon that level. Also, I'll be covering NCERT as well. Don't worry at all. Okay. Now let us see the dimensional quantities of which are some important ones. If somebody asks you dimensional quantity for area is what? Length into breadth. So it will be what? L into L. It will be what? L square. So what will it be? M to the power 0, L to the power 2, t to the power 0. This is what? This is the dimensional formula for area. Then volume will be what? Simply L will be to the power 3. Rest all will remain same. We know speed is what? Distance upon time. Distance is what? Length upon time is t. So it will be what? M to the power 0, L to the power 1, t to the power minus 1. This is what? This is speed or velocity. Then if we know acceleration is what? Rate of change of velocity, that is velocity by time. Velocity की अभी अभी निकाली है, lt to the power minus 1 upon time, that is m to the power 0, l to the power 1, t to the power minus 2. This is the dimensional formula for acceleration. Then let's come on to the force. Force is what? Mass into acceleration. Mass is m, acceleration is lt to the power minus 2. Simple. Then let's come to momentum. What is momentum? It is product of mass and velocity. So mass into velocity. Mass is m, velocity is lt to the power minus 1. This is what? This is the dimensional formula for momentum. Similarly, we can find out the dimensional formula for any quantity. What you should know? You should just know the formula, and standard is m to the power a, l to the power b, t to the power c. This is how you can find out the dimensional formula for various quantities. Okay, so all those children who are interested in practicing the questions, I am giving you a few questions. You can practice them, and in the next video or rather in the last of the units and dimensions, when the whole chapter will be completed, I will be uploading the answers to all these questions separately. Alright, so you can write down the questions, and if you have any doubt, you can very well comment in the comment section. Find the dimensional formula for. These are the questions which I am giving you. Okay. In the last of the units and dimensions, I'll solve all the questions separately. I'll make a video. You can just note down the questions and try them out. What is the dimensional formula for gravitational constant? Gravitational constant. I am giving you the answer side by side. You can write down the answer. So answer for this is m to the power minus 1, l to the power 3, t to the power minus 2. If you get this answer means your topic is verified. M to the power minus 1, L to the power 3, T to the power minus 2. See, I am uploading the answer side by side itself because if I'll upload at the end, it will become a whole mess up. So what you can do, stop the video here, try it out, then again switch on the video and see how I have solved. If you are correct, then very good, and no, then see the solution. Gravitation constant. We know according to Newton's law of gravitation, F is equals to G m1 m2 by r square. G का निकालने से G will be FR square upon m1 m2. Force अभी we found out that is mLT to the power minus 2 into R square is L to the power 2 into M square is M cancel, so we get M to the power minus 1, L to the power 3, T to the power minus 2. That is the dimensional formula for gravitational constant. Alright, then second part we can try for power. We all know what is power. Power is work upon time. So minus 2 into L upon T. Find out M L square T to the power minus 3. This is the simple answer for power. ठीक है? Okay, so इसी तरह से let us see the third question. Third question says find the dimensional formula for Young's modulus. Do note down all these questions. These are all important questions. Young's modulus. See, Young's modulus is what? It is like this gamma we write down, and it is what? It is longitudinal stress upon longitudinal strain. Stress is what? Pressure, same, that is force upon area. Strain is what? Delta L by L. This we'll read in the solids chapter, no need to worry. So it will be what? F by A. Okay, so it will be what? It will be just give me a minute.